Welcome to Chris Ngumi online mathematics lesson. Today we are looking at an example of a function. Now, if you look at the board, if you are given, let's say, -1 is less than or equals to x, x is less than or equals to, let's say, 2. This is the range of values of x, and we said x is an independent variable. So that means we have a table of values like this. We have x-axis, we have x values and we have y. So this interval is given as -1, 0, 1, 2. It's obtained like in a number line. We know when you have a number line, the middle is 0. To your right, you have 1, 2, 3, and to your left of 0, -1, -2, like that. So this interval covers -1. That is if the numbers are whole numbers, or if the numbers are integers. So we have -1 to 2. Now let's say we have a function. Let's say we have a function y is equals to 2x plus 1. Y is equals to 2x plus 1, and we said this can be represented as f of x is equals to 2x plus 1. Now remember, this x is the independent variable and it is always known as the domain, whereas this y, which is the dependent variable, it depends on the value of x. This y is said to be the codomain. Now we want to get these values of y, which is the dependent variable. So in our chart, we'll have a domain. This is x, and we have a codomain. This is y. Y, or we used to represent f of x, the same thing. So if you look at it, so if our x here, if our x is -1, which is the domain, so our -1 will be here. So 2 minus 1, which is like we are having -1 here, the domain. So if x is -1, is that okay? Which is the domain, then what will be this f of x, which is the y? So here we're going to substitute the value of x as -1. So 2 times -1 is -2 plus 1. -2 plus 1 will give you -1. So that means our codomain is -1. Now if our domain is 0, so we're going to put 0 here. So this is mapping, or let's say we have a function here from the domain to codomain. So if our x is 0, if our x is 0 here, which is the domain, what will be our codomain, which is the dependent variable? So we have 2 times 0 is 0 plus 1, we have 1. So here we have 1. There's an arrow here. So this is 1. So this is mapping 1. So let's put it here, 1. So if our x, or which is the domain now, is 1, so that means x, the domain is 1, what will be the codomain? So 2 times 1 is 2 plus 1 is 3. So that means here we're going to have 3. That means our 1 is mapping 3. Likewise, if we have our independent variable, which is x, if it is 2, which is the domain now, so we have 2 here. Is that okay? So we want to get the dependent variable, which is the y, or which is the codomain. So we are going to put 2 here. If x is 2, so that means it will be 2 times 2, which is 4 plus 1, which is 5. So here we're going to have 5. So 2 is mapping 5. So here, this is 5. That is why in the other class, we define a function is a relation or a mapping. So this expression here is a function. We say is a mapping or a relation that assign every element in the domain to an element in the codomain. That we said is a function. So if you look at this function, is one-to-one and onto. So any function that is one-to-one and onto must have an inverse. So we shall continue from here in our next class. Take note, we said a function is a mapping that assign each element in the domain, this each element said to be our input, to an element in the codomain, which is said to be our output. So if you look at this, why we say is one-to-one, because every element in the domain has an element in the codomain. Has one element in the codomain, and is onto because the range is equal to the codomain. Now you can go ahead and solve this. If you are given a table of values or a range of values from, let's say, -2 less than x, less than or -2 less than or equals to x, x is less than or equals to, let's say, 2 also. So use this function f is equals to 3x minus 2 to produce the domain and the codomain and show their mapping. Take note, mathematics is a beautiful thing. Learn it. Thank you and bye-bye.